Hello everybody, welcome to the second part of the basic skills test. Let me get my pointer up. So we're mostly dealing with percents, decimals, and fractions, starting with fractions in this part of the review. You'll have to maybe turn the volume down just a little bit. Okay, now in the very first slide, I said that we could convert fractions to decimals to percents in any way among the three. Okay, so I want to represent 0.025 as a reduced fraction. Now, when you read this properly, okay, it's 25 1,000ths. 25 and the 5 is in the thousands place, so 25 1,000ths. So as a fraction, it's 25 1,000ths. Then you reduce your fraction. So I can divide the top and the bottom by 25, and that reduces to 1/40. Now, if I wanted to change this to a percent, okay, I could do that a couple ways. Percent means out of 100, so I could change this fraction to an equivalent fraction with 100 in the denominator. However, that's not going to be easy because 40 doesn't go into 100 easily. So when I want to write this as a percent, okay, I can move this decimal to the right two places and add the percent sign. Okay. So 0.025 would be 2.5%. Move it over two places, add your percent sign. If you take 2.5 and divide it by 100, then you're going to come up with 0.025. If I want to take the percent and write it as a decimal, okay, remember that is per 100, so I'm dividing by 100, which means I move the decimal back to the left two places and drop the percent sign. So I'm going to drop the percent sign, move the decimal back, and then I have to put in any zeros that are placeholders. So when I move this back two places, I've got an empty space here that needs a 0 to hold the decimal in the right place. Okay, I've got a little bit of a mess over here, but I'm not going to re-record this. We'll just see what it is when we get to it. So we have 7/80, and we want to represent that as a decimal. Okay, now if we could get 100 in the denominator, we could just take the numerator, right, and write it over 100 and read that as a decimal. But that's not going to be as easy to do as just remembering that a fraction bar means division. So this is just 7 divided by 80. Now, I want to make sure that I can divide this, okay, because I know 80 is not going to go into 7. So I can put a decimal point and add as many zeros as I need to, and then perform my division. Okay, so here I went ahead and it's written, I've got 4 zeros after the decimal place. If I need them, I'll use them. If I need to add more, I will. So now, it's important that you do this because the first thing you do, the decimal place for your answer needs to be moved straight up. Okay? And now, we'll do our division. So, how many times will 80 go into 70? Nada. How about 700? It'll go in there 8 times. So 8 times 80 is 640. When I subtract, I get 600. How many times will 80 go into 600? How about 7? 7 times 100. 7 times 80 is 560. Subtract, now you see where these numbers fit in. And how many times will 80 go into 400? 5 times with no remainder. So that is our decimal equivalent. If I want to write this as a percent, I already know what the decimal equivalent is, right? So I just move the decimal place over to the right 2 units and add my percent sign. When we have signed numbers, okay, these are integers, a number is smaller the furthest it is to the left, and it gets larger as it goes to the right. Okay, but the first thing we talk about is what is absolute value. So absolute value is the distance a number is away from 0, regardless of the direction. So both 5 and -5 are 5 units away from 0. So they both have absolute value, which is represented by these bars, of 5. Okay, now if they're additive inverses, if they are the same distance from 0, but opposite in sign, because when you add those two, you get 0. So we have a question that asks us, what integer is the additive inverse of 135 negative? So I want the integer that's 135 units away from 0 in the opposite direction, so that would be positive 135. Okay, now we have a problem. We have this nested absolute value. So we want to find the absolute value of the opposite of the absolute value of 912. Okay, now when we follow the order of operations, we simplify grouped expressions first, and we always start with the innermost. So the innermost expression is the absolute value of 912. Okay, well, that's 912, okay, right? And then, so when I take the absolute value of 912, I get 912, but it still has the negative in front of it because that's outside. Now it's all inside the absolute values, so it's actually positive. Here, again, the further you go to the left, the smaller you go. The further you go to the right, the larger you are. So I want to order these from smallest to largest. So -26 would be furthest to the left, and then -23, -19, -8, and then 3 would be farthest to the right. Now when we add integers, okay, so we're adding numbers that may or may not have signs. If you don't see a sign, it's assumed to be positive. Okay. If we're adding like signs here, so if we're adding 2 positives, 2 negatives, we add the absolute values and keep the same sign. Okay, so this one, the B part, we're adding the same side. Both are negative, so I add the 27 and the 8 absolute value and then keep the same sign on my answer. When I add unlike signs, I find the difference between their absolute values and then take the sign of the number that has the larger absolute value. So here 9 is positive and 21 is negative. So I find the difference between 21 and 9, which is 12, and then I take the sign of negative because the 21 has a larger absolute value here, and it's negative. Subtracting integers. So when we subtract, okay, when I said when we divide fraction, it means to multiply by the reciprocal. Okay. When you're subtracting, it's the same thing as adding the opposite in sign. So we can change each to an addition problem and then find our answer using our addition rules. So 9 minus a negative 25 becomes 9. This changes to positive, and this also changes to positive. So now I'm adding 9 and 21, and that's going to give me 30. Negative 27 minus a negative 8. Okay, so I've got to change the operation to addition and change the sign on the 8. Okay, with that plus plus, I don't need that second plus. Now I'm adding negative 27 and 8, so I find their difference, which is 19, and take the sign on the 27 since this has a larger absolute value. Now multiplying and dividing integers, you just follow, multiplying or dividing, and then you determine the sign of your final answer. If you are multiplying like signs or dividing like signs, you always get a positive answer. And if you multiply or divide negative signs, excuse me, opposite signs, then you always get a negative answer. So if it's a multiplying a negative times a positive, you're going to get a negative. So here are two multiplication problems. So 9 times the negative 21, we multiply those 9 and the 21, you get 189. And then I'm multiplying a positive times a negative, unlike signs, so I have a negative answer. Here, negative 27 times a negative 8, I'm multiplying like signs, so I multiply the two numbers, but my answer is positive. Okay, when I'm dividing, I do my division and follow the same rule. So if I take a negative 36 divided by negative 6, I'm dividing like signs, so I get 6 as the answer, and it has a negative. It has a positive. I was noticing this little thing that's down here. So the answer is positive since I'm dividing like signs. Here I'm dividing unlike signs, so 36 divided by 6 is still 6, but it's negative since I divided unlike signs. Now I want to give you a few tips. There's a couple questions that I didn't cover, but they're just using percents and decimals. So if you have any questions about those, I can send you some solutions to those. But pretty much, if you know how to do what we have here, you should be fine. But here's a few tips, because if you don't follow these tips, you may not be fine, even if you study all this stuff. One of the most common mistakes I and other teachers of this course have seen is that a lot of times students will just use the first attempt just like a trial. Okay, they know they have 3 chances. Well, I'll just go see how I do on the first one. I'm not going to study. Then they almost always, for the majority of students, I wouldn't say almost always, but the majority of students do not pass the first time because they don't prepare. So don't ever use the first trial as just to see, oh, what's this test going to look like? You already know what it's going to look like. That's what the practice test is for. Won't be the same numbers, but it'll be the same problems. Same type of problems. Okay? So you need to study as hard as you can the first time, because you don't want to make the mistake of not studying. Reduce your chances of passing by reducing your number of attempts, and then try to figure out what's going on. So, just a tip, don't ever use the first attempt as the trial. This isn't like, oh, I think I'm going to go to the restaurant and try this meal tonight. No, this is going to mean whether or not you can pass this class or not. So the other thing is, work through the practice test without looking at any answers first. Okay, I gave you the solutions, but don't look at those first. Practicing mathematics is not merely reading over examples. Your brain is not made to process math that way. If you were memorizing exact facts, that may be what you do. Like if you're studying a set of facts for a history test. But just reading over the facts is not really studying them. Okay. Really studying them means you test yourself to see if you know what it is. You don't just assume, oh, I read it, so I know it. Okay. Now, I'm saying all these because I have been guilty of some of this stuff in the past. So if you work through the practice test without looking at the answers, then you know which ones you already know how to do. So then don't study those. Spend your time working on the ones you missed. Find other examples, not just the same problem over and over again. So you can find a book, you can type in Google, adding fraction examples. They'll pull them up. You can even type in adding fractions worksheets. And you can find free worksheets that have plenty of answers with them and see if you can work those. It's free. Some of them you have to pay for, some of them you don't. But as future teachers, it's a good thing for you to practice going into the web and looking up free resources online. So you want to find other examples and get practice problems. And then if you need help, you can look at videos, you can see me, you can see a tutor, any of those things. So figure out what you're not sure about. Okay. Math is something that your brain doesn't process by memorization. Okay, yeah, the facts, if you're learning math facts, yeah, you memorize those. But if you're learning processes, how to work through things, you learn processes like riding a bike or nurses giving someone a shot. You learn that by practice. You don't just read the instructions. I would not want someone reading the instructions and then hooking me up to a machine and drawing out my blood. I want someone who's been doing this for a while to actually do that. Okay, math is the same way. Since you're learning processes, you have to learn it through practice. And when you learn through practice, what you learn goes into long-term memory. What you learn through memorization goes into short-term memory. And short-term memory is not something you can pull up during a test. You can, but you only have access to so much memory at a time. But if you understand a process, then your brain will pull up the process. You don't have to know all the little facts. You know the process so you can work through it. Okay, so there are only a very few people who can memorize mathematics, and they can only do it up to a certain point. Then after that, you have to learn it by practice. You really learn it because you understand it or know it. Okay, so don't, do yourself a favor. Don't assume you can do things that your brain is not wired to do. Okay, so if you'll do this, and then if for some reason you don't pass the first time, but I am believing you're all going to pass the first time, because I believe you have 2 weeks. This will be your second week to really prepare for this. You will get another attempt, okay? But one of my demands, I guess you would say, or one of my things is I don't want you to take it a second time without coming to see me or arranging some sort of online meeting, okay? Because I want to know that you understand what you missed and you know how to work it. So let me know if you need any help, and I hope this helps you. Don't wait till the last minute.